Hi again. My name's Will, and I'm the DigiKey Ambassador for Purdue University. And today, I wanted to share with you some tips that I have on taking your prototype to the next level by designing and manufacturing your own custom printed circuit board. Now, before I get into the exact steps on how to design and manufacture your circuit board, it's important to discuss the actual projects that a circuit board is well suited for. It's always nice to start your projects in the breadboarding stage, so that way you can iron out any of the small details and change components much easier than if you had to change the whole design of the circuit board and get it remanufactured. Now, if you are working on a project that already has a well thought out design and it's been proven in a lot of test situations, now is a perfect time to start thinking about what kind of circuit board you need and move on to the next steps of your design phase. Another reason you might want a circuit board is if you consider your design and where it's going to be located for most of its life. If you are designing something that's going to be located in your car or near a washing machine or somewhere with a lot of vibrations, a printed circuit board might be a very good option. Now that we have all of that out of the way and we know that it's time to start working on designing a printed circuit board, let's move into the next steps into what it actually takes to design one. Have you ever wondered how all of the electronics in your car can communicate so fast and so reliably? Me too. That's why one day I sat down and I researched how all these modules can interact, and I learned that the core of the whole system is what's called the CAN bus. It's a two-wire bus that runs around the whole vehicle and allows all of the modules in the car to communicate all at once. This is incredibly interesting because since it's only two wires, it's very robust and easy to manufacture. And since it's a proven concept and been used for years, a lot of modules support it and make it a lot easier to add your own modules or even diagnose your vehicle if something goes wrong. Another great thing about the CAN bus is that it's widely adopted, and there's even components for the Arduino available to allow multiple Arduinos to communicate over a CAN bus. And it's for that reason that I decided that this project would be a great example of designing a circuit board, since I could design a circuit board that could hold all of the components for the CAN bus communication and then create a circuit that would allow two Arduinos to communicate with each other. But that's enough talking about the introductions of the project. Let's get right into it. The first step is to create the schematic for the circuit you are building in your PCB design software. I'm using Autodesk Eagle, but there are a variety of other options available, including some online that don't require downloading any application. In the schematic, it's important to make sure that all of your connections are exactly the way that is in your breadboarded designs, since the circuit board design software will use these exact connections to tell you where to place the copper traces used for the connections. Once the schematic is fully assembled and double-checked, it's time to move into the board editor mode. The first step is to move each component to wherever you believe is the best in order to fit the project. This could mean putting connectors near each other and keeping similar purpose circuitry as close together as possible so as to keep all of the connection traces short. Remember though, you can always move components or traces if there's a problem later down the line. You notice that there are a bunch of yellow lines connecting between the components. These are to show what pins need to be connected to each other using the absolute shortest distance possible. In reality, we won't be following those lines, but they are a great start to visualize how far we need to go. Now it's time to connect the components together. Using the routing tool, we can click on the device pin and the connection is made much more obvious. When drawing the trace toward the pin it connects to, it's important to try to stay clear of other pads and holes so you don't accidentally block a connection that you need to make later. It's also important to save all of the ground connections for last, as they are just a little bit different. On this board, I'm using two component layers, so that means that I can have traces on either side. This is crucial since sometimes connections need to cross over each other, and that just wouldn't be possible to do in just one single two-dimensional plane. As you make connections, you'll probably find that some connections need to be moved and rearranged. You may even come across a connection that can't be made perfectly in either layer. What do you do now? Well, this is a great time to incorporate another crucial design element called the via. A via allows you to effectively move a trace from one side of the board to the other in order to cross over a signal path. It's important to use them sparingly, but they are perfect for those specific occasions where one connection just can't be made without traveling to the other side of the board. Eventually, all the connections are made and it's time to finally connect all of the grounds. Every software is a little different, but in Eagle, the polygon tool is used in order to draw an outline around the whole board. Once the connection is filled in, all you have to do is name it ground, and the ground pour is complete. In Eagle, you can even visualize the ground plane by clicking Rat's Nest, and you'll notice that the board is now made of mostly a large copper sheet connecting to all of the ground connections. It's important to create these pours on both sides of your board in order to properly isolate signals and prevent traces from interfering with each other. Finally, the last step is to label any aspect of your board you like with the text tool and export the Gerber file. From there, you are ready to use the DigiKey PCB manufacturing service and get your project build sent right to your door. And I actually went ahead and ordered some of these ahead of time and assembled the project for you. As you can see, this design is already much more compact than the original on the breadboard. It also has the added benefit of securing all of the components in a way that keeps them from accidentally shorting into each other. I hope you enjoyed this quick video on PCB design, and I hope it demonstrated to you just how easy it is to take your project to the next level. For more detailed information on this topic and more, make sure to check out maker.io for all the blogs and how-to videos on this concept. Until then, thanks for watching. My name's Will, and have a great time making.